Hello and welcome to STEM with Mr. N, where I perform different demonstrations and explain the science behind what we're seeing. This week's episode is a Christmas themed episode as I explore dissolving with candy canes and Skittles. Let's check it out. At one point in this video, I'm going to set up an experiment and ask you to make a prediction about what you think will happen. So look out for that coming up at some point in this video. Candy cane recipes can be found in books from the 1800s. However, there is a common folklore story that says that a choir master in Cologne, Germany in 1670, who was fed up with children making noises during worship services, asked a local candy maker to make sticks of candy for the children, but to put a hook on one end to remind the children of the shepherds that visited the baby Jesus. From here, candy canes spread throughout the rest of Europe and are commonly associated with Christmas time, often having white, red and green stripes and tasting of peppermint. However, different colours and flavours are now available. This week, I'm going to be using candy canes to explore dissolving. For this activity, you will need 2 jars or glasses, some hot or cold water, identical candy canes and a timer. First, I'm going to get a jar of cold water and a jar of hot water and set these on the table, and you'll see I've labelled these using post-it notes. Then I'm going to hook a candy cane over the edge of each jar so that most of the candy cane is down inside the water, with a little bit sticking out the top hooked onto the jar. I'm then going to set a timer on my phone and I'm going to check in on the candy canes every 5 minutes. However, I'm going to leave the cameras running so you can see in fast time the changes that are happening to these candy canes. After 5 minutes, you'll notice that some of the colour has started to strip away from the candy cane in the cold water, but a lot more colour has stripped away from the one in the hot water. After 10 minutes, more colour has stripped away from the one that's in the cold water. However, when I went to lift the one in hot water out, the bottom part of it just completely broke off, that it is dissolved right through where the top of the water level is. I'm going to leave the candy canes another 5 minutes to see what happens to that bit of candy cane that's now floating around inside the hot water. After 15 minutes, you'll notice that the one in the cold water is a bit thinner than when it started, but it still has some colour, whereas the one that was in the hot water, that bottom half that broke off, has now completely dissolved in the water. Dissolving is when a substance becomes part of a liquid solution. In this case, the sugar in the candy canes was becoming part of a liquid solution in the water. So why did the candy cane in the hot water dissolve faster than the one in the cold water? This is because when you heat up water, you're giving the water molecules energy, so they move about much faster within the water. This means more water molecules are hitting the candy cane in the hot water faster and more regularly than they are in the cold water, and that is what speeds up that dissolving process. It's important to note that when I'm setting up this experiment, I'm making it a fair test. The only variable I am changing is the temperature of the water. I'm using identical candy canes, identical jars. I'm doing the experiment at the same time and the jars are sitting in the exact same place in the room. The only thing which has changed is the water temperature. Now I'm going to set up this experiment again. I'm going to fill up another jar using white vinegar, which is water mixed with acetic acid, and this is at room temperature. I'm going to fill up the jar and again I'm going to hook a candy cane onto the top with most of the candy cane down inside the white vinegar. Again, I have labelled my jar as white vinegar on a post-it note and I've set a timer on my phone. This is the experiment I want you to give me your predictions on. Do you think the candy cane will dissolve faster in the white vinegar than it did in the hot water? Do you think it will be slower than the hot water but faster than the cold water? Or do you think that it will be slower than both types of water? You can leave your prediction in the comments. You can email them to me at stemwithmrn@outlook.com, or you can leave your predictions on the STEM with Mr. N Facebook page. You'll find out the results of this experiment in next week's video. But now I'm going to move on to looking at dissolving with Skittles. For this experiment, you would need 2 plates, some hot and cold water, and some Skittles. The first thing I'm going to do is just set my 2 plates next to each other and create a pattern of Skittles in a circle round the edge of the plate. I am doing identical patterns on both of these plates, and again I'm using identical plates. The only variable I am changing here is going to be the water temperature. I'm going to use post-it notes again to label the plates, with the plate on my left being cold water and the plate on my right being hot water. Then I'm going to pour cold water onto the plate on the left and hot water onto the plate on the right at the same time, and watch to see which one has the fastest reaction dissolving the Skittles. As you probably expected following the candy cane experiment, the Skittles that were on the plate with hot water dissolved faster than those on cold water. And again, this is because hot water has more energy, so the water molecules move around faster and they are hitting in to the sugar on the sweets faster and more regularly than on the cold water. The reason we get that rainbow pattern though, rather than all the colours mixing, is because as that coloured sugar is coming off of the Skittles, it is spreading out into the water, going from a concentration of high sugar into an area of less sugar. But all of the sugars are moving at the same time, so the concentrations of sugar coming from each Skittle are the same, and that is why they don't mix. They are all equally balanced, and that's what gives this nice rainbow pattern. After a while, if you leave these plates sitting here, the colours will eventually start to mix as you reach a point where so much sugar has come out it's got nowhere else to go but to mix in with all the others. With both of the experiments I've done this week, you can change it up by trying different liquids to see what effect that has on the speed of the dissolving of the sugar. There's really no end to the types of liquids you can try or the temperatures that you can try. So why not have a go experimenting yourself and see what's going to make things dissolve the fastest? Don't forget to send me your predictions for that experiment with the candy cane and vinegar. You can either leave these in the comments on this video, email me at stemwithmrn@outlook.com, or leave your predictions on the STEM with Mr. N Facebook page. Well, that's all for this week. I hope you enjoyed it. As always, if you did, please hit the like and subscribe buttons to stay up to date on all future content. I would like to take this opportunity to answer any science questions you have about any science topics at all. So feel free to email me at stemwithmrn@outlook.com and I'll get back to you with answers to your questions. You can subscribe to the channel by pushing the button here, and I've added links here to the other STEM demo and explanation videos I've done, here to my STEM career interviews, and here to my series on 100 scientists who influenced the world. This has been STEM with Mr. N's Christmas themed video looking at dissolving with candy canes and Skittles.